Alrighty guys, welcome to 3.7. This lesson is going to be over synthetic division and rational root theorem, okay? The reason that we use these two different methods are just to help us factor, okay? And they're really, I know you guys make fun of me because I say this all the time, this really isn't too bad, okay? When we look at this example that we see here at the top, we're just going to work our way through this, okay? And I'm going to show you how we use this method. So we'll start off with just synthetic division. So we have this function here. We're going to be dividing it by x plus 1, okay? So the first thing it wants us to do is to write out all the coefficients and constants in order, okay? So we know coefficients are just the number in front of the variable, okay? And we know constants are just those numbers that don't have variables. So what I'm going to do is just write those out. So in order, it goes 3, 4, 2, and -1. Okay, if there so happened to be a missing term, so for instance, if this just jumped from 3x cubed to 2x and we didn't have this x squared term in there, then I would need to put a 0 in as a placeholder. Okay, we didn't run into that on this one, so we don't have to worry about that right now. But if that happened, we'd put in a 0, okay? Next step is to set that divisor, which is what we're dividing this function by, which is x plus 1, set that equal to 0 and solve, okay? And then this is going to become what we call our ledge value, okay? So when I take that x plus 1, my divisor, I set that equal to 0, and I just get x equals -1. So this is what you're going to hear me call my ledge guy, okay? Ledge term, ledge guy, whatever you want to call it, okay? The next thing we're going to do, drop our first coefficient down, multiply that term by our ledge term, and here we're going to model this below, and then add those numbers. So how this works, okay? Here's my ledge guy. So I'm going to put him just like that. Now I'm taking those coefficients and constants that I just drew out, and I'm putting those to the right of my ledge guy. And now, just to go old school here, I'm going to draw a line, just like what we used to do with our addition problems when we were younger, okay? So here's what we got. Very first thing, drop down the first coefficient, okay? That's step 3. So drop this guy down. So that's all I've done so far is just drop that 3 down, okay? Now, I take this term, 3, and I multiply it by my ledge guy. So 3 times -1 is just -3, and I write that right here. And now this is just an addition problem. 4 plus -3 or 4 minus 3 is just +1. And now I take this term and I multiply him by my ledge guy. 1 times -1. And now 2 minus 1 is just 1. Take this guy, multiply him by my ledge, 1 times -1, -1 again, and now we got -1 plus -1, which is -2. Okay, why did I just do all that? What did this give me? Okay, so what I actually just did, even though we didn't do any division, was I just divided, okay? Seems pretty easy, right? Dividing without having to do any division. Okay, so what is my answer going to look like now? And here's how we do this, okay? So since I just divided, and I divided by an x plus 1, so all I did here was I shrunk this function, or that polynomial, I shrunk that down by 1 power. So my highest power there is x to the 3rd, okay? So I just divided by x plus 1. And now what's left is just going to be an x squared, okay, because I just took away 1 power. So this first term here just tells me that this is going to be a 3x squared. The next highest exponent would be a plus 1x. Then I have a constant, because again, I'm just going in descending order. But then I have this -2 left over. And all that -2 is that is my remainder, okay, from my division problem. And so to write that, all I've got to do is just to write that term and put it over my divisor, which was x plus 1. And that is my answer. Okay? So don't overthink it, don't overcomplicate this. If you need to scroll back and watch this again, that's fine. But we're going to do some more examples, so don't freak out. Okay, so we've got another one here. We are going to do this one together as well. So solve the following problem using synthetic division. First thing I want to do is find my ledge guy. That's what I'm going to do first. So I got to set x plus 3 equal to 0. I know I just subtract the 3 over. So x equals negative 3. That's my ledge. Okay? Going to write him right here. And now I just need my coefficients and constants in order. So it looks like my first one's just going to be a 1. Then I jump from an x to the 4th to an x squared. Didn't I skip x to the 3rd? Yeah, I sure did. So I need to put a 0 there for x to the 3rd. But then I have a 3 for x squared, a 1 for x, and then a 4 for my constant. Draw my line. Drop him down. 1 times the ledge, 1 times negative 3 is negative 3. Now I add these two numbers together. Negative 3 times negative 3 is a positive 9. Add these two numbers together. 12 times negative 3 is a negative 36. Add these two numbers together. And negative 35 times negative 3 is a positive 105. Wow. So I end up with 109. Now I just want to write this as my polynomial. I started with x to the 4th, so that tells me that this first thing is going to be an x to the 3rd minus 3x squared plus 12x minus 35 plus 109 over x plus 3. That's it. Okay? So, both of these examples that we've just done, we had a remainder, okay? And if you remember back to when we used long division, back when we were younger, if we had a remainder, that meant that that number did not go into the other number evenly, okay? So this is the exact same thing. So if we're using this synthetic division and our remainder is 0, that means it is a factor. If it's not 0, it doesn't go in evenly, okay? But if it does come out to 0, then it is a factor. So if, for instance, on a test or on the EOC, ACT, whatever you see, if it gives you those two things and it asks you, okay, is x plus 3 a factor of this polynomial? Well, you could just use synthetic division, and if you get a remainder, then absolutely not. It's not a factor. But if your remainder is 0, then it would be, okay? So I want you to go ahead and try examples 4 and 5. Then we're going to go over them, and we'll keep going today. Okay, so for this one, you should have got your ledge guy to be 2. You should have then had 2, 7, 0, because there was no x term, and negative 10. Drop down that 2. 2 times 2 is 4. These add to be 11. Times 2 is 22. These add to be 22. 22 times 2 is 44, and we end up with 34. So this was not a factor, but to rewrite it as a polynomial, my first term is going to be 1 degree less than the first term was originally, which is just going to be an x squared. So 2x squared plus 11x plus 22 plus 34, can't really read that, 34 over x minus 2. Okay? And then for this next one, very similar. Ledge guy should have been negative 3. We should have then had 2, negative 1, 0, 3, negative 5. Draw your line, drop down your 2. 2 times negative 3 is negative 6. Negative 1 plus negative 6 is negative 7. Negative 7 times negative 3 is 21. 0 plus 21 is 21. 21 times negative 3 is negative 63. 3 minus 63 is negative 60. Negative 60 times negative 3 is a positive 180. And we got a pretty big remainder there. So this should have been 2x to the 3rd minus 7x squared plus 21x minus 60 plus 175 over x plus 3. All right, let's keep moving along. Okay, moving right along here. So now we're going to be talking about what we call the remainder theorem. So what this means is your remainder is the solution to the evaluation of a number using synthetic division. Okay, what the heck does that mean? Let me explain. Okay, so don't write this. But for instance, what we've been told so far about if I needed to find f of 2 for f of x, all I would do is I would just plug in 2 everywhere where I see an x, okay? And then I'd type that in my calculator. I could do it or in my head if I wanted to, but if I type that into my calculator, I would get 34. Again, don't write that down, okay? That's what I know so far about evaluating functions. But here's what I want to show you, and this is what I do want you to write down, is that I can use synthetic division, okay? If I didn't, let's say I was using, or I was taking a test and I couldn't use a calculator, okay? And I didn't want to do all that in my head, which is understandable. I could just use synthetic division, and whatever remainder that I get, it should match up with this if I did it correctly, okay? So for instance, if it says f of 2, I'm just going to go ahead and use 2 as my ledge guy, because again, it's not like x minus 2, okay? It just actually gave me the ledge guy. And now I'm going to go and pull my numbers, so 2, 7, 0, negative 10. Now I'm just going to do synthetic division, so I'm pulling down that 2. 2 times the ledge is 4. 2 times 2 is 4. 7 plus 4 is 11. 11 times 2 is 22. 0 plus 22 is 22. And 22 times 2, we get 44. 44, and negative 10 is just going to be a positive 34. Okay, see what I just did here? 34, 34. They match. Okay, so that is a way to check your answer too. But if you do this correctly, synthetic division should give you the same remainder as if you evaluated this problem for f of 2. Okay, I want you to go ahead and try example 2. So p of negative 4 is going to be your ledge. Write out your coefficients and your constant, and then perform synthetic division on this. Okay, so again, ledge guy is negative 4. You should have put 1, 0, because we're missing an x to the third term, negative 5, positive 4, and 12. Draw a line, drop down your 1. 1 times negative 4 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 4 is 16. Negative 5 plus 16 is 11. 11 times negative 4 is negative 44. 4 minus 44 is negative 40. Negative 40 times negative 4 is 160. And 12 plus 160 is 172. So that is my remainder. And if I had to write this as an answer, p of negative 4 equals 172. Okay? That is it. So please make sure you're understanding that. If you need to go back and rewatch those, great. If you need to go ask a question, please make sure that you do that. Okay, so just a little recap. Again, remainder theorem, it just means that the remainder that you get after completing synthetic division is the evaluation of that value in the function. So just like, for instance, f of 2, if I plug that 2 into my function and I got 34, right? Same thing happened when I did synthetic division. I still got 34 when I put 2 on that ledge, and I did synthetic division on that, okay? So that's all the remainder theorem means. Your remainder should match your evaluation, okay? Factor theorem now. So this is a little bit different, okay? But what this states is that when you're using division, if your remainder, if your remainder is 0, then the value you're dividing by is a factor. We just talked about this, okay? For instance, if I did long division, right, back in whatever grade we learned that, I don't even know. So if I did 16 divided by 4, 4 went into 16 4 times evenly, okay? So 4 would have been a factor of 16, and we know that, okay? This works the same way. So if I do synthetic division and this x plus 4 comes out with a remainder of 0, that just means that x plus 4 is a factor, okay? So let's try it. So that is x plus 4, which means I've got to set that equal to 0 and find my ledge guy. So now we'll go ahead and put in our coefficients. So we got 5, 16, negative 15, 8, and 16. We didn't have any zeros because we didn't skip any values here. And now, drop down my 5. 5 times negative 4 is negative 20. 16 plus negative 20 is negative 4. Negative 4 times negative 4 is a positive 16. Negative 15 plus 16 is 1. 1 times negative 4 is negative 4. 8 minus 4 is 4. 4 times negative 4 is negative 16. And 16 minus 16 is 0. Do we see how our last term, our remainder here, is a 0? So yes, this is a factor. X plus 4 is a factor of this polynomial. Okay, so next up, it's asking me, is x plus 2 a factor of this polynomial? And it says if it is, then find the remaining factors, zeros, and roots. Okay, so first part of the question is just find out, is x plus 2 a factor of that polynomial? So I want you to pause here. But real quick, I do want to fix this here. Okay, so that should be negative 6x squared. Okay, that was a typo as well. So I want you to pause here. I want you to solve this. Find out, is that a factor? Okay, what you should have done, negative 2 was your ledge guy. We then had 1, negative 6, negative 1, and 30. Drop down 1. And bam, remainder of 0. That's what I wanted, okay? Now, the next part of this question is that we need to find the remaining factors, zeros, roots, okay? So we've dealt with this before. We've found all of these things, but here's what we're gonna do. So we know for a fact that x plus 2 is a factor. That's what we just found out with synthetic division, okay? Now, what I have left here, if you remember, is another factor, right? A polynomial, though. It's going to be a little bigger than x plus 2. It's going to have one exponent less than the exponent of 3. Okay, so this first term is going to be x squared minus 8x plus 15. So that is a factor of this as well. But I know that I can factor that down further. I know that for a fact, okay? Because that's what we've been doing for the last unit. So, first thing I want to try, since this is a trinomial, I do want to try the x method, okay? It will work. Sometimes it won't always work, okay? And we know that if it doesn't work, we use the quadratic formula. But let's try it on this. 1 times 15 is 15. Negative 8 goes in the bottom. Two things that will multiply to give me positive 15, but add to give me negative 8. And negative 3 and negative 5 actually do work on this, okay? So then I just want to factor by grouping. So I get x squared minus 3x minus 5x plus 15. Group first 2, group second 2, okay? X comes out on the first, negative 5 comes out on the second, and I end up with x minus 5 and x minus 3, okay? So that's perfect. That's ideally what I want every problem to do, so because I didn't have to do the quadratic formula, which was fun. Okay, so my first factor we knew was x plus 2. It's a factor. X minus 5 is also a factor. X minus 3 is also a factor. So that's what I'd write in that blank right there. That's how I write a factor, okay? how do I write a root? That's whenever I convert it to like my ledge guy, okay? So I just set it equal to 0. So x minus 2, if I set that equal to 0, I'd subtract the 2 over, I'd end up with -2. Same thing with x minus 5 equals 0. I'd add the 5 over, get +5. Add the 3 over. So those are my 3 roots. And then technically to write these as zeros, that just means write them as intercepts, okay? So -2, 0, 5, 0, 3, 0. So they're all the same thing, just 3 different ways to write it, okay? So now what we got going on, rational root theorem, okay? So this is just kind of throwing all of this together, okay? So here's what we got. It says in the last examples, we were given the values to test to see if they were factors. But what if we were not given the factor? What if they didn't give us the factor? Okay, we would have to use what is called the rational root theorem. And this is a big, big, big Algebra 2 concept, okay? If you go home tonight and your parents ask you what you learned at school today, you can tell them that you learned the rational root theorem, and they'll be like, oh my gosh, I remember learning that. They might not actually remember what it is, but they probably remember the title of it, okay? But here we go. We're given the following equation, and we're asked to find the roots, but they didn't give us any, okay? So we've got to find at least one so that we can use our remainder theorem, okay? So what we've got to do, always the checklist that you want to go through mentally here. Is the equation set equal to 0? If it's not, all you got to do is change that f of x to a 0. We've done that before, okay? Can I factor this, okay? Because that would be a really easy way to find a factor, is if I could factor this, okay? So let's look here. This is how many terms? It is 4. Okay, so I could try to do factor by grouping, because that's the only thing I know how to do when I have 4 terms. So for instance here, these would have an x squared in common, and there would be a 2x plus 1 left. Here, these would have a -1 in common, which would then give me a 2x plus 1. Okay, good news, my parentheses match, so this 0 equals x squared minus 1 times 2x plus 1. Great. Factored it. Awesome. It says, can you use the quadratic formula or complete the square? So if I can't factor it by grouping, by the x method, then it says, can you use that quadratic formula? But remember, that quadratic formula, it only works with powers of 2. So if, for instance, they gave me like 2x to the 3rd up here, that wouldn't work with the quadratic formula. It's got to be power of 2. Got to be your highest. So this doesn't work for everything, okay? And then if none of these options are available, you could always graph it, especially if you're on the EOC, taking the EOC, and that Desmos option is there. We're going to learn how to use that later on, but definitely type that into Desmos and see what you got going there, see where you cross that x-axis. But there's also the way we can solve it out algebraically. And again, this is what we call the rational root theorem, and this is what we're learning today. But definitely try to factor it first before you go into this, okay? Because again, this one factored really, really nicely. Like x squared minus 1 equals 0 and 2x plus 1 equals 0. Well, this is actually just a difference of squares 1, if you remember. So it'd be x minus 1, x plus 1. So I'd get x equals 1 and -1. And then here I would subtract the 1 over, divide by 2, so x equals -1/2. So those would be my 3 factors there. So that one factored really nice. Okay, but they're not all going to factor nice. And that's where this rational root theorem comes into play. So we'll go ahead. We will look here. we're actually going to use that same equation, and I'm going to go ahead and just write those answers that I already got up here just for reference, because I'm going to show you why this works. It will work for everything, but again, if you can factor it, you don't have to use this. How we do this though, we list all the factors of the constant, okay? And again, that's always the term that doesn't have the variable. So it's the number without variable. If you need to write that down, you don't have to write that down if you know what that is, but if you're wanting to take good notes, go ahead and do that. So for instance, any factors of my constant here, so my constant is -1, so technically +1 and -1 would be a factor of that. Then I want to list out all the factors of my leading coefficient. So again, we find our highest exponent. It's usually the one in the front, okay? Almost on every single question that we do for the homework and the test, I believe, it will be in the front. One thing you might see in like college algebra is they switch them up on you and they want you to put them in order, but don't worry about that for now. But my leading coefficient here, the number in front of that term is just 2, okay? So technically all of the factors of a +2 would be ±1 and ±2. So now we just need to write out all the factors of that constant, which we just found, and put them on top of the leading coefficient. I'm going to abbreviate there. Okay, so for instance, constant was ±1. And leading coefficient was ±1, ±2. Okay, and then we test each value using synthetic division. We know if it's a factor if the remainder is 0. Okay, so for instance, looking here, my possible factors then would be 1, +1 over +1, which would just be 1, -1 over +1, which would be -1, okay, -1 over +1, which would still be a -1, I don't need to write it twice, and then -1 over -1, which would still be a +1, again, I don't need to write that twice. And then we have +1 over +2, which would be a 1/2, and we'd end up with -1/2 as well. And those would be my only 4 factors that we need to test, okay? So for instance, I'm just going to start with the easy one, the very first one, which is just a +1. And hopefully I get lucky and I find that this is a factor, because then I don't have to keep going. So 1 is my ledge guy. I need to go up here and I need to find my terms. So we've got 2, 1, -2, -1. Line. Drop down the 2. 2 times 1 is 2. 1 plus 2 is 3. 3 times 1 is 3. -2 plus 3 is -1. Sorry, +1. 1 times 1 is 1, and -1 plus 1 is 0, remainder of 0. So yes, 1 is a factor. Thank goodness. I don't have to keep going with this, okay? I'm done. Not quite though. So now, I've got a leftover polynomial. I know that my very first term is going to have an exponent of 2, because that's 1 less than 3. 2x squared plus 3x plus 1 equals 0. And now I just need to factor this. So let's try that. I'm going to try X method. 2 things that will multiply to 2 and give me add to 3. 2 and 1 will work. So 2x squared plus 2x plus 1x plus 1. Go ahead and group. These have a 2x in common. These just have a 1 in common. And 2x plus 1 times x plus 1 equals 0. So now I set both of those terms equal to 0. So x is going to equal -1/2. X is going to equal -1. And x is going to equal +1, because that was the term, my ledge guy, that worked. okay? So those are my 3 answers, and that is how I use this. All right, so next examples. We are gonna try this one. So it says list all the possible roots for each polynomial and then find the actual roots and zeros for each example. So here we go. We're gonna do this one together. Don't have a ledge guy, okay? But the first thing I do is I find all of the factors of my constant. That's gonna go on top. So 10 would be, 1 could go into 10, 2 could go into 10, 5 could go into 10, and of course 10 can go into 10. My leading coefficient is just a 1. So that's all that goes on bottom. So technically all of these factors are just basically 1, -1, 2, -2, 5, -5, and 10 and -10, okay? So first thing I wanna do, start off easy, and I'm just gonna try +1. So we look, using synthetic division, I've got 1, -2, -5, and 10. Drop down my 1. 1 times 1 is 1, -2 plus 1 is -1. Keep going here. And is this remainder a 0? Nope. This one doesn't work. So I'm gonna keep those same values, but now I'm trying my next number. Now I'm gonna try -1. So this can get a little monotonous, okay? Because sometimes you will have to try more than one. You won't get so lucky on the first. So -1 doesn't work. Now we'll try +2 because that's next. 1, -2, -5, and 10. Ooh. Yes, that one works, okay? So 2 is a factor. Awesome. So now what I have left here, x to the third was my highest power, so this is going to be an x squared plus 0x minus 5 is 0. So that's just x squared minus 5 is 0. Well, I know that since this is a power of 2, I can add this 5 over. Square root both sides, and x is going to be plus or minus the square root of 5. Okay, it was x to the third, so I knew I was going to have 3 answers, okay, because again, your highest exponent should always be the amount of roots that you have, okay? So I've got x equals 0, x equals a positive square root of 5, and a negative square root of 5. It does say to write those as zeros, so technically that's how I would do this. I don't care if you go that far, okay, just as long as you realize how we got those answers. Okay. Sometimes we will have to use the quadratic formula, and this example B here is one of those examples, okay? Yeah, I want you to go ahead and try this one. So go ahead and set up your rational root theorem and try synthetic division, see if you can get a root to work, and then go from there. Okay. So if we look, constant is 1, leading coefficient is 3. So this is what I get for my possible roots. So basically 1, -1, 1/3, and -1/3, okay? We'll start with a +1 because that's the easiest, all right? 3, 1, -1, 1. Drop that 3 down. And we'll keep going here. That doesn't work. We'll try -1. And this becomes a 0. Perfect. That's what I wanted it to do. -1 is a factor. Awesome. Don't forget that one, okay, because that's the one we just found. So now I just need to take this and make that into my polynomial. It's going to have an exponent of 2, because again, that's 1 less than what it gave me up here. So 3x squared minus 2x plus 1. Okay, so hopefully you tried X method on this one. Newsflash, it did not work, unfortunately. So what you should have done then, quadratic formula this, so A is 3, B is -2, C is 1. So -2 plus or minus the square root of -2 squared, which is 4, minus 4 times 3 times 1, all over 2 times 3, okay? And when you simplify this down, you're actually going to end up with an imaginary number. And I'm going to go ahead and just give you, just to save some time here, I know that you know how to use this, so I'm just going to go ahead and simplify it for us. We end up with 1 plus or minus I, square root of 2 over 3. So technically that's not a real root, okay? That's an imaginary root, which is fine because we can have those, okay? So we've got two answers here, 1 plus I square root of 2 over 3 and 1 minus I square root of 2 over 3. And then we have our other answer. So we knew we were going to have 3 answers, and we did, except for only one of them was a real number, which is fine. You'll have that, and we're going to talk about why that is here in a second. So back to this fundamental theorem of algebra. It states that the number of roots, zeros, or x-intercepts, whatever you want to call them, is based upon our highest power. So these will only fit into 2 categories. They'll be real or they'll be imaginary. And knowing this, and what we learned from the last section, we've got to list all the possibilities for zeros that the following polynomial might have. So based on the fundamental theorem of algebra, my highest exponent in this equation is 3. So I know I'm going to have 3 roots. Based on the imaginary root theorem, we are going to have both positive and negative imaginary roots. These come in pairs. That's why this is important, okay? Because every single time we do that quadratic formula, we end up with, for instance, on that last one, it was 1 plus or minus I square root of 2 over 6, or over 3, sorry. Okay, so do we see how that is 2 answers there? That's 2 roots. There's always going to be a plus and always going to be a minus on these. So no matter what, if you're going to have an imaginary root in an equation, you're going to have 2 of them. Or you might have 4 of them. Or you might have 6 of them, okay? But just know that they're coming in pairs. You're never just going to have 1, okay? So we're going to keep moving on from this. Okay, so next up we have just looking at a polynomial. Don't have to solve anything out. I just want to know, just by looking at this, how many real and how many imaginary am I going to have? Well, I first look at how many roots total am I going to have? And that's always the highest exponent. So I know 5 total is what this one's going to be. Now let's talk about imaginary. We said they come in pairs. So I could have 0, 2, or 4. I couldn't have 6 because that would exceed my limit here. Okay? So that's a possibility there. I could have 0, 2, or 4 imaginary. But now let's talk about how many real solutions I could have. And we said that that's just the factors of our constant, possible factors of our constant, over possible factors of our leading coefficient. So a positive 1 over positive 1 would be a 1. Negative 1 over positive 1 would be negative 1. And then positive 1 over negative 1 and negative 1 over negative 1 would still give me these same answers, so I don't have to write those again. So 2 possible real solutions. If I use both of them, there would be 3 left. Can I have 3 imaginary? No. If I used 0 of the real solutions, do I have 5 imaginaries? No. So the only way this will work is if I have 1 real solution and 4 imaginary. Okay, so just by process of elimination. Let's drop down to this one. Okay, I know I'm going to have 8 total. Possible real, so I don't have a constant, it's just 0, over leading coefficient, which is negative 1, so it could be plus or minus 1. Well, 0 divided by anything is just 0, so 0 is the only thing I got going here. Number of possible imaginaries, though, would be 2, 4, 6, 8. Well, if I have 1 real, I can't have 7 imaginary, right? Because I've got to get these to add to 8. So I'm just going to have 8 imaginary. okay? Same thing in number 3. My highest exponent is 1. And just by looking at this, I know I'm going to have a real solution because I know how to solve that, okay? There's not going to be any imaginary on this. But if I have 1 total, again, these come in 2s, ain't going to work, okay? Because I've got to have 1 total. So it's going to be 1 real. All right, so putting all of this together, we are going to actually just skip number 1 just for time's sake. We're just going to do number 2 here. So first things first. I can try to group this, but it's actually not going to work with grouping. So what I'm going to move on to is just my rational root theorem. So possible constant coefficients are plus or minus 1, plus or minus 2. Leading coefficient is 1. So it looks like I'm going to have 1, -1, 2, -2. Okay? So we will start with 1. That's my ledge guy. My numbers are 1, 1, -1, and 2. Drop down the 1. 1 times 1 is 1, 2, 2, 1, and it doesn't work. -1 is next. Same terms, just different ledge guy now. Drop down our 1. And -1 doesn't work. Let's try 2. Two doesn't work. And we got -2 left. Probably gonna work. And it does. Okay, perfect. -2 is a factor. That's what I needed, okay? I'm actually, just for room's sake, hopefully you didn't write quite as big as I did. I'm gonna erase just so I can get all that out of the way. So here's what I know. I know that -2 is a factor. And I know that this is my polynomial that is left, which is just going to be x squared minus 1x plus 1, okay? Try to factor that with the x method. And unfortunately, that's not going to work. So I am going to have to do quadratic formula on this, but that's okay. A is going to be 1, B is going to be -1, C is going to be 1. So a -1 plus or minus the square root of -1 squared minus 4 times 1 times 1 over 2 times 1. So we end up with 1 plus or minus the square root of -3 over 2. So this is just 1 plus or minus the square root of, I square root of 3 over 2. I just pull out that I. So x equals these 2 roots and -2. And that is it. Okay? So your homework, you have got 5 Delta math problems and then the 1 homework sheet that's in the packet. Please make sure you turn in that homework sheet to Canvas. If you are struggling, please, 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 just because I am gone does not mean that you cannot go get help from anybody else, okay? You could go to any math teacher in this hallway. However, I would recommend going to any of the other Algebra 2 teachers, Mrs. Schlitt, Mr. Borcherding, Mr. Millard, and Mr. Gilmore. They would love to help you, okay? So please don't be shy. If you need help, go ask them or ask a friend that knows what's going on. But again, this is how this works. Feel free to scroll back and watch more of this video if you need it. And good luck. Thank you guys. I'll talk to you soon.